What would happen if you were to bring a tiny piece of the sun to Earth? Short answer, you'd die. Long answer, it depends which piece of the sun. Like most of the matter in the universe, our sun is neither solid, liquid, or gas, but plasma. Plasma is when stuff is so hot that the nuclei and electrons can separate and flow around freely, which creates a goo-like substance. So you can imagine our sun as an extremely big, spherical ocean of very hot goo. The deeper you go, the denser and weirder the goo becomes. So let's bring 3 samples, each the size of a house, to our lab here on Earth and see what happens. Our sphere now carries twice as much energy, as much as 25 kilograms of TNT, but this time as heat. For a dazzling instant, this plasma would glow with 1,000,000 times the brightness of the sun seen from Earth, instantly lighting fires throughout our lab. But a few milliseconds later, those fires are all that's left. The plasma has cooled to harmless gas floating up from the flaming ruins. What if we go deeper? Third sample, the radiative zone. Here the plasma is about 2 million degrees Celsius and so dense and tightly packed that it creates a sort of maze for itself. Energy in the form of photons tries to escape but has to wander for hundreds of thousands of years, bouncing endlessly from particle to particle until it eventually finds an exit and creates an explosion with the force of, well, the sun. If we get the sample in Paris in the morning, the citizens of London would see what looks like a second sunrise, but one that gets brighter and brighter and hotter until London burns to ashes. In a radius of about 300 kilometers around the blast, everything would be burnt. The shock wave would travel around the Earth multiple times. Most buildings in Central Europe would be flattened, eardrums would rupture, and windows break across the continent. The explosion would be apocalyptic, possibly human civilization ending. If humans did survive, we could count on the dust blown into the atmosphere to create a small ice age.